for some reason. I'm Andy Gumbrecht. I'm a Tommy Tribe consultant, a committer at Apache Tommy. I'm here today to not specifically chat about Tommy. I'll try steering clear of Tommy as much as I can, but obviously I'm going to be a bit biased when it comes to application servers because Tommy's just the best, really. So we've all had those days where, you've been knocking one out in the bedroom, an application, and it needs to be tested. And so you make up that fancy test, and everything seems to be fine. You go to demo it at your boss, everything's fine. And then it gets shipped to that production server, and it's not fine. You've missed something. You thought you covered everything. I'm going to be teaching you, I'm not going to go into like a tutorial mode when it comes to Arquillian. This is just a light introduction to Arquillian, which is a big topic. The first thing we need to know is what is Arquillian. Don't be a femic. Basically, Arquillian, which I used to call Arquillian, just like everybody else, it's called Arquillian. These are the enemy in Men in Black. The guy that came up with this was Aslak Knudsen, who's the lead developer. And basically, you need to befriend the Arquillians. These are the little guy in the big guy that got killed. We're not here to invade your world. We just want to take it over a little bit when it comes to your testing application servers, because there is a better way of doing things. So as I mentioned, Aslak Knudsen is the lead developer on Arquillian. He runs the show. He's the project lead. He's always open for communication. It's an open source project, so there's nothing closed source behind Arquillian. If you want to actually go and hack on Arquillian, then you can see how it's built. Pete Moore is the co-founder, and again, any of these guys I'm mentioning today, including myself, feel free to contact us if you're having any issues with the Arquillian testing. I'm going to finish the talk today on Alex Soto's project, which is Arquillian Cube, and that is basically taking Arquillian testing, which we're going to learn about, and putting that on Docker. So, really trying to build your production time environment on a Docker image. And everything, like I said, open source and Apache 2.0 license. That means nobody is ever going to own that product. There may be some commercial support services offered off those products, but Apache 2.0 belongs to you, belongs to me, belongs to everybody. No one can ever own that or change that license. So for all intents and purposes, we're going to be talking about testing. Everybody knows @test. I'll actually ask for a hands up on this. Who's not used @test? Exactly. Everybody is now using @test. We used to extend those test classes, and now it's all annotation-based, and we're all using @tests. So if you've all used @test, then there's a bit of a silly question. Do you test? Yes, we're all testing. What kind of tests are you actually testing? Your tests are not just there to test your code. They're there to aid your development. So almost going towards test-driven, not quite test-driven, but actually saying you've tested the code and it facilitates the further development of your application. If you've tested something and it's constantly being tested and you change something in your application, then obviously it's going to fail the test if you break one of those tests, and that's what we're doing. So it's a knock-on effect of testing your code. So what types of tests are you actually doing? Some people focus on one or two different types of tests. We've got the classic unit test, whether that's a sociable unit test, one that collaborates with external resources, or a very simple unit test that doesn't actually communicate with anything other than itself. We've got integration testing, where we might take several elements that we're testing, put those together, and we'll perform then a greater functional test on all those tested elements in a traditional sense. When it comes to application servers, well, we're going to have problems. We need to do all of them. We can't just focus on one single test. You should be doing all of the above. It's quite important to test the smaller elements of your application. But when it comes to an application server, how are you then going to put that all together in a developer environment? It's okay on the production side, but we need some way of ensuring in a very quick fashion that the tests that we're writing are actually going to work in our production environment. And Arquillian is a big, big step in moving your isolated, collaborative or non-collaborative tests into a real production environment where we're saying, I'm going to deploy that application that I'm physically going to test onto an application server and test that tiny piece of code in the real sense of an application, not just isolated. So it takes all those elements and puts them together. I'm going to have to have a quick drink. It's not like I do this every day. You get to see how much my hand's shaking now. So when we're starting to test our application server, what do we need? We need an environment that's actually going to be familiar to us. We don't want to force people down a particular path to say, this is all new. Everything, you need to change your ball game. All that testing you've been doing in the past, throw it all away. Here's something new. That's not what we're doing. The tests need to be portable. They need to be portable on any of the containers that you're going to be using. Things like Tommy, and WebSphere and JBoss and some of the others. You can't dictate in your environment necessarily the application your server is going to be using. What I often see is people are developing applications on a lightweight application server, which they then deploy to a heavyweight application server. So what you're actually doing when you're running with your tests, you're testing against your lightweight application server and deploying on something completely different. It's a different entity, it's a different beast. And we should really try and avoid that as much as possible. So we're not going to pick and choose our application server. Oh, look, a typo. We're not going to choose our application server for our test environment. We're going to make our test environment fit the application server that we want. Obviously, tests need to remain executable. We don't want to generate a whole new environment that you have to run these tests in. So, one, we're not changing the testing techniques that you're already familiar with, and we don't want to change the environment that you're running your tests in today. So it needs to run in your IDE. Arquillian is, I said it, I owe you all a beer. Arquillian, it runs in all the most common environments, notably NetBeans, IntelliJ, Eclipse, and any of the others you can think of. There's a plugin for Arquillian, so you can run these natively in your IDE. They need to run on your build tool, so if you're most commonly using something like Maven or Gradle or any of the other build servers or build environments, they need to be able to run within that build environment without changing anything. Also for Jenkins, if you're going to be deploying to your CI, then you don't want to change the infrastructure of your CI just to fit in with this new form of testing your application. So they need to fit within the existing frameworks, which is NTest and JUnit. So I'm going to give you a quick rundown of the architecture of this thing. How does it work? Before I move on to code, just a bit of information, visual information, to help you move into the world of Arquillian testing. The very basic thing is pick your container. The number of containers listed here, that's not an endless list. There's probably about 15 now in the plugin repository. So you can pretty much pick and choose which application server you're going to be running this environment, hopefully your production version. So then you select a container to start. And I don't want that one. I want that one. Does anyone recognize that logo? So you're picking your container to run. What you then need to do is package your application in some way. So in the context of a unit test, we want it to be nice and small and neat, concise. And how are we going to do that? We're going to package that in the packaging that you would actually package it on your production system. So whether that's a EAR file or an enterprise file or a WAR file or a jar file, we're going to take that information that you want to put on the application server in the exact same format that you would normally put it on the application server. So you're basically building your application. You don't have to put your entire application in, but most certainly the unit that you want to test in your application. To do that, and we'll see this later in the code, we use a project called Shrink-Wrap, which is basically a collaborative product with Arquillian that builds applications for application servers. And these are the three basic formats, which is your Java archive, just a jar file, web archive, which is a WAR file. I really wish I just called it WAR archive, and enterprise archive, which is an EAR file. And so what we can do is build programmatically your application, which we will then deploy to our application server. Once we deployed it to our container, we actually run that test as a full-blown application within your production environment. So that server is configured to be as close to your production environment as you can make it in a test environment. And you run your test. And again, we'll be looking deeply at code. I'm not going to be using Darkula for the demo because it doesn't work. But basically, you can see here very quickly, we're going to run with the Arquillian class, which tells JUnit we need to do some sewing together of stuff for this test. It's not just going to be a simple unit test, it's going to be an Arquillian test. We create a deployment, and this is in its most basic form, the deployment that you can see. Using the shrink wrap, we're literally just going to add a few classes to this application. We're going to create a beans XML file. We do that because in EE6 you need a beans XML to switch CDI on. We don't need to have anything in it, which is why we can just pass it in as an empty asset. All that is doing is building the application that is going to have a beans XML generated for you within the application. It will then ship that off to the server and run the test. Obviously, once we run the tests, we need the results from those tests. So you're actually physically going to deploy your application to your server, which doesn't necessarily need to be a local server. So there are two ways of running these tests. One is local, so you can have your application server on your machine, or you can have a remote server. So in the instances of some of these big, expensive application servers, it's not viable to have those on your desktop. And certainly if you had them on your desktop, you wouldn't be able to compile any of your applications because it uses up all the resources. So you can actually configure a remote server that you're going to deploy your application to. And obviously all application servers have some kind of deployment mechanism. And this is all utilized by the Arquillian framework to ship your application off to the application server and test against it and return the results to us. It then undeploys your application, and if it's a local instance of your container, it will actually shut that back down. You can have the option to start a local application container and run a suite of tests all against the same application server and shut down at the end. Or you can restart your application server, which, if you have the resources, I'd always recommend is you start your application server, deploy the application, and then shut down your application server. If you have a big, heavy application server, that's not necessarily viable because it takes too much time of your testing. If you have a quick, lightweight, embedded application server, something like Tommy, that starts in a few seconds and shuts down in a few seconds, then that becomes more viable. And again, I do want to harp on about Tommy. Something we have in Tommy is we have random ports. So we can start tests in random ports, which means you can actually run concurrent application server tests on your system, and it won't block. So that's enough about how the stuff is put together. I'm going to move on to some code stuff. Again, always cross fingers. These things sometimes go wrong. Let's hope not today. There we go. So here we're just seeing the familiar at test, nothing more, nothing special about this. This will obviously run in your IDE. I'm not actually going to run it. That would be quite pointless to show you that IntelliJ can run a test that does nothing apart from assert true. What I am going to do is show you a little bit more. Obviously, you're here to see Arquillian in action. And like I say, at the end, we'll finish with Arquillian Cube, which takes it to a next level. This is a very basic application. It's created using a Maven archetype. It's just a very, very simple bookstore, but it contains all the elements. And these projects are available for you to download. If you come and see me at the end, or you look me up on GitHub, these projects are all available on GitHub for you to use. And they do contain just about everything within the EE range, so we can use this little application to build tests that are actually really testing some of your EE applications in a real way. So I shall start with a simple test. So this is about as simple as it gets. In fact, wrong. We'll do the light test. This is, no, well, right, simple test. You can see on the left we have our application, and on the right is the code that's going to build our test. In our deployment, I actually need to then build my application to resemble my real application in some fashion that I'm going to test against. And so what I'm doing is adding the classes that I'm going to test against. I'm also adding my persistence XML. I'm going to add the beans XML to switch on CDI. So that all looks pretty simple. I could just be building a Java archive or an ER archive. I'm choosing a WAR file in this instance. And it looks way simple. You know, all we're doing here is literally adding a name for our project. We're adding some classes. We're adding our persistence XML. And we're telling our application to switch those beans on. So when this deployment fires up, all that background is sewn together specifically for your application server, and this application will be shipped into your container and run. So when we actually run the test, all we're going to be doing is looking up our bean that we need to stash our books away with and retrieving that information back from the server. So this small test is going to be as small as it can be for the test that we want to do. However, there's a huge amount of sewing together in the background to put all that on the application server that we usually deploy on. So rather than just a very simple component test, this is a component test, functional test, and integration test all in one, and is much more close to the real environment that you're going to be deploying your applications on. So if I just run this away. And here, really, it's an application server, so you're not going to see much user interaction. But what this is doing is actually physically starting the application server, and the log file in this instance is our way of checking that things are actually firing up properly. It's deploying our application as a real application, shutting down the server, and returning some information. That's all happened in a few seconds. So I've literally built my real application, shipped it to that Tommy that's running in the background, run the test against the application that's running on the server, and shut the server down. And Arquillian enables that in literally these few lines of code. So before I move on to the light test, we'll take a quick look at the Arquillian XML file. So how does it do this? How does Arquillian fire up the application server, deploy our application? How does it know how to do this? This is a very simple extension to JUnit. The Arquillian dependencies are added to your project, and those dependencies basically look for this Arquillian XML file, which tells, in addition to the dependencies, how do I need to start my server? This block of code is going to be quite different depending on the application server you're using, but you're always going to have an Arquillian XML file. In this instance, the HTTP port for us is -1, which tells us when we're booting up our application server in the background to use random port. That gets fed back through the API to Arquillian, and again, we can run concurrent application server tests. So we can be testing very, very quickly, and that is it. So to enable Arquillian to fire up our application server, we're supplying it with a Arquillian XML file, and that says, okay, this is going to be an Arquillian test. We add to our test, simple test. Like test. Always the Arquillian run with, which says we're going to run with, using our XML file, this deployment, and here's my test. The light test is just to show you slightly more of the capabilities of shrink wrap and how we build our application server. Obviously, these applications that we're going to be building and deploying, they're not going to be a very simple application that I'm displaying here. They're going to be big, complex beasts with loads of business logic. And if we had to type in all our classes and add all our files, it would be extremely tedious, and we wouldn't want to do it. So shrink wrap here in our deployment allows us to be very powerful with the way we're building our applications. And again, I wouldn't do this for every single test. I would have an abstract class, and you would build your application as you would usually test against it in your abstract class and extend that class with your own test. So you're only adding very lightly to the application every time you're building your test. But in the background, you know you've got this very complex beast that is deployed to a very complex application server. So here we're adding namespaces. And we can bring in all the dependencies that our application requires. Shrink wrap will actually look up on Maven, so without you having to touch and add those dependencies into any POM file, you can add those dependencies to your application descriptor here, and Maven will be used, Maven Central will be looked up, and all these dependencies were pulled in. So you really have full control in your deployment of how your application is being built. And again, this is to bring you as close to your production environment as possible. Again, we're adding our persistence unit, Beans XML to switch on CDI, and then we're going to merge stuff. And this is, I've just put this in basically down the bottom here, merge. So this is, for example, if you're extending an abstract class, you could do the merge in the deployment of your extension. And so you don't have to create the whole deployment for every time you run the test. You create basically what you're going to be testing. And again, very simple, the book test. So obviously, if you've cached your dependencies locally, so everyone will have their M2 repo local, these tests get faster and faster as you build them. So the first time you run a test on a new environment, you don't have to provide anything other than the Maven infrastructure, and all those dependencies will be pulled in. It will utilize your M2 repository in the background, and so the consequent runs of the test are going to be as fast as you would normally test against. Just to go a step further, and I don't need to run this one, it's just, again, building on what you've already seen. It can be as complex or as simple as you make it. If your application is complex, you need to make your test fit the environment that you're testing against. And this is just basically to show you that the whole Arquillian framework provides everything for your application server testing. So here, although it looks rather complicated, it's actually quite simple once you've used it once or twice. We're just building a typical web XML. So our web XML, production web XML, might be a big, fat, heavy beast. We don't need it all. What I'd like to do is just create a very simple programmatic version of that web XML. So you can see here, again, using the imports, we can create the complete production environment. And this is a kind of one-time, let's get this ball rolling kind of development, and then you can extend it each time for your test. So yeah. we're doing a RESTful call, a SOAP call, sorry, and doing a comparison of the SOAP. Here, the only thing I really need to point out here is we're using the HTTP client. So this is a real HTTP call to my application server. So in the sense that we've run the application server, it's running in the background. How am I testing? How am I going to do a real client test? And this is a very simple example of using a real HTTP client to call your RESTful endpoint that's deployed in your test. If you tried to do this manually, it's an awful lot of work. And this just basically makes it as simple as possible. So here we're physically testing using a client, totally separated from our application server, a remote endpoint that we've deployed. So now we're going to do something special. I know it's a dry subject, but this is as close as we can get to our production environment, outside of actually having our production environment. What I'm going to lightly go over now is Arquillian Cube. So Arquillian Cube is an extension to everything you've just seen. All it really does is facilitate Docker. So we can actually provide a Docker image that really is our production system. I can't emphasize enough how fantastic this mechanism is. This is literally taking an image snapshot of your production system and creating a Docker image of your production system that you can now test against. Obviously, in your real environments, you're never going to test against your production system. There will be a whole world of CI to go through before it ever gets to your production box. But this way, you can give your developers basically a snapshot of the real production system with whatever you want on that image. So if you've got a database, you would include this in your image. I have a Docker image prepared, which is basically a Tommy, Postgres, everything sewn together for any kind of testing you would ever want to do on the Tommy side. And I would suggest you go away, and if you're going to play with this, is take an image of your production system and just create a Docker image from that system, and then start testing at the end. Now, it's quite an intensive process, so it's not something that you're going to have on your developer box necessarily, because your production system is probably going to be big, fat, bloated, and these tests will really take time. But something that we do and what we consult for our customers is to have your CI box Docker capable, and you can actually then run your tests on your CI. So these are the final tests, the complete integration of your application on your real application server. So when I run this, I already know it's going to take more than a few seconds to boot up. There's some entropy going on in the background, but this is literally Tommy booting up. It's deploying several other kind of applications, so our deployer application, our console application, the root application, and various other things are on this server. So now I'm not testing in an isolated fashion. So what we've seen with Arquillian up till now is we're testing in a very still, isolated way. Even though we're integrating our application server, we're not collaborating with other applications. With a Docker image, I can have applications pre-deployed. So if I need to communicate with my database, or I need to communicate with other applications running on the same application server, then I can do this. And so this is now Tommy booted up on a Docker image. Very simple. I'm sure everyone's had a play. Who's not had a play with Docker? One or two. So yeah, Docker. Everyone knows Docker. Everyone knows application servers. We now know Arquillian, and we know Docker, and we want to put those two together. So for this application demo, this is just going to be a very simple hello world servlet. And this is on my machine, but if we imagine, this Docker is completely separate from my system. So it's a virtual machine running on my machine. It's very, very separate from my developer environment. How are we going to get this test onto my Docker? So my Docker image can already be running. Again, the Arquillian can fire up the whole Docker container for you and deploy your application to the Docker image. Or you could just have a Docker image running. So you could have various test environments running on Docker machines ready to deploy to. So how are we going to enable this test? We've already seen the Arquillian XML file. This is the extension to JUnit. All we're doing is adding an extension to Arquillian. So this is how we add plugins to Arquillian. We're just defining a Docker image. So this would be my Docker image. And when we fire up the container, rather than actually deploying the application server, Arquillian Cube is saying our application server is a Docker image. So we will deploy to Docker. We're going to poll the application server on the exposed ports. So down the bottom, we've got port bindings. These are the ports that are exposed by the Docker image. This is a real application server running on these endpoints. I'm going to start up. I'm going to poll for that application server. When I find it, I'm going to deploy my application to the application server running on the Docker image, which is my production environment. And then I'm going to run my tests. And that is as near as you're going to get to testing on your production system without actually testing or breaking your production system. So again, made to look very, very simple. We're still using our Tommy container, but this time, this extension is saying, let's do this somewhere else. And our test is exactly the same. I'm just switching on some static logging. In fact, I should get rid of that. We're creating our deployment, and this time testable is false. This means we're not going to be testing local, we're going to be testing remote. This works in a very similar way. I mentioned before that you have a local container or a remote container. When you create your deployment, it's tested on the local container. Unless I say it's false, it's going to be deployed to the remote container. And that will actually go, not all application servers have remote deployment enabled, but in the sense of your production environment, you have your Docker image now running, and you can tweak that Docker image to allow you to test against it. So you can open up the doors a bit and allow deployment of applications over a remote boundary to that application server. And this is what testable is saying. We're not testing it here. We're going to actually physically ship that to the Docker image, and we're going to test that application remotely. An alternative to that, I have commented out here, which is run as client, which basically does the reverse. It says, I know my test server is local, but I would like my client test to be isolated. So what that is doing is it's isolating the class loader of your test so that there's no conflict between your application server class path and your client test class path. And again, we're going to be using an HTTP connection to do a real remote test to the Docker image running on my machine. Before I do this, so this little snippet here is basically going to shut down any running instances because I've been playing with it earlier. What I usually do is integrate this into my Jenkins build, and all this does is ensure that Docker is clean and ready to go, especially when tests fail. If you have a test that's failing on a Docker image, then you really need to stop Docker and restart, make sure that the images you're testing against are clean. And so this is something that's not actually in Arquillian Cube yet. I have submitted a patch for it. It's in process. But this is just to say I would like a flag to clean up Docker and make sure that every test I run is starting on a clean image. So here, this is basically, again, something that doesn't have a UI for us to see, so we're looking at a log files to see what's going on. That's why in the test I switched on trace logging, so we can actually see the test going out to the Docker container. In this instance, the Docker container is not running, so it's actually physically doing the deployment of the container. Then it's deploying Tommy on the container, starting up the database, sending across the application, running the application on the Docker image, returning the results, and shutting down Tommy, then shutting down the Docker container. So everything's contained, and here the test has passed. So the test has actually, again, in this sense, gone out to something completely remote, into my production environment, and the test that's come back as true means that this is run successfully on an environment that is as close to my production environment as I can possibly make it. And that, ladies and gentlemen, is a little bit quick, but that's pretty much it. Do we have any questions?
Yes. So basically, you said that you put everything into a Docker container, and that's how you are testing.
I put everything into a container, and that's how we test it, yeah?
Okay, but if I already have a Docker container, are you going to just utilize that, or do you put my Docker container into your testing container?
Sorry, can you say it again?
What if my application already packed it into a Docker container? Are you going to use that, or are you going to still use testing?
That's entirely up to your test. I mean, if you don't supply a deployment, so the question is, if my application is already running on my Docker image, so I have my production system, I have my application on my Docker image, can I just simply test that application from Arquillian? Well, of course, yes, you can. You don't have to switch on, in this sense, the cube side of things. The application would already be running in a Docker image. You would fire up that image and you would test against the deployed image. So that's basically up to you how you would then write your test.
Another question, do you integrate with Gumbrecht?
Yes. So in the sense that Docker is deployed, you can obviously build your environment for something like Kubernetes where you're actually having a cluster and you're deploying to your cluster. That's entirely up to you how you build your Docker image. That's in the hands of your Docker environment, how you would fire that up. The goal here is really to take those steps towards testing whatever it is you're testing in the real environment that it's actually going to be running in. I think it's fairly traditional to say today most people are testing on something they're not actually running in production. Hands up who always tests on their production system. Nobody. Nobody tests on their production system. So what this is showing you is, and what this is asking you to do is say, take your production system, look at how it's running, deploy an application, and give that to your developers as an image that they can then use. So put it into the CI infrastructure. So you don't want your developers testing on Docker images unless they're going to be really quick. This is a full-blown example: launching a database, launching an application server, and running all that in real time. It can be just running in the background, and I can deploy to it. I don't need to deploy that every single test. So I can deploy it at the start of my test suite and undeploy it at the end of my test suite. Something that's also necessary, I find, with EE testing is state. So we need to run our tests in order. Usually unit tests aren't run in order. In fact, I didn't point this out on one of the tests, which is the ability to run your tests in order. Which is going to be on... So we've got test in sequence. So because we're actually now deploying to our application server, we can change the state within the application server. So one test is for the creation of something, and another test is for the deletion of something, and another test is to make sure that that's been done properly. You could do that all in one unit test, but it's much nicer to break those down into the unit tests that we should be doing. So testing each individual piece of logic. You want to know if the insert fails, you want to know if the delete fails, and you want to know if it's been cleaned up afterwards. You don't necessarily want to do all that in one unit test that tests those three things together. Let's keep those separate. And if that's on a Docker image, you can really write something to your back-end database and retrieve it from the back-end database and delete that from the back-end database without killing your production database. Obviously, we don't want to be deleting and testing against our production database. But here, this environment that we're now building in Docker is as close to our developer environment and as close to our production environment as we can make it to keep both parties happy.
We're deploying this is usually expensive. Does Arquillian has any support of cleaning the state between tests?
Individual tests would be the way of cleaning tests. So you would just write another test. There's many directives. Again, this is a light overview. But if you're going to get serious about this, obviously read the Arquillian documentation, read the Docker documentation, and read the Arquillian Cube documentation. There are many parameters that can govern this kind of testing. So yes, we can clean up after tests the environment. And as I mentioned previously, using Tommy, so I didn't want to say that name again, but with the random port, we'd developed Tommy, and yeah, we were testing back to back, and it just became really annoying because we're deploying to a build bot at Apache, and those tests are running back to back, and it was just a run of like 18 hours to test Tommy, and so we just came up with this fancy idea. At the time, we didn't think it was particularly fancy, which was just giving this thing -1 and run that test on a random port. And today, I don't know of any other application server that does that or enables you to just say, run this on a random port. Obviously, being a Tommy developer, I'm going to lean towards Tommy, but I didn't realize how powerful that was. I happened to mention that the last time I did this talk, and someone said, what... random, why would you do it random? And it's like, so we can run tests together, and found out that was the only application server that currently, using this kind of mechanism, runs concurrently. But again, you can deploy at the beginning, so to resolve that issue, rather than running full application servers currently, you can deploy the application server at the beginning of your test suite and undeploy the application server at the end of your test suite. And once the server's up, the deployments of each test is milliseconds. It's really quick. It's as quick as your application server can take a WAR file and deploy it on the system.
So, how does Arquillian fit for a very complicated environment in terms of lots of different service calls, external to the application, going maybe different languages as well, interfacing with COBOL, etc. Would you be actually instantiating the whole environment with all those applications, or is it typical to mock out any of your?
Yeah, I mean, you can mock out, when we're deploying something like this, it's very hard to do it with Mockito. It is possible because you can deploy, obviously, the Mockito libraries on your application server in your image or with your application server in the embed environment. But it becomes slightly more different. I actually got the right project open here, which is my mock book service. So because I'm deploying to an application that doesn't have a database, so all I'm saying is my database is going to be a mock. This is a very simple mock object, and this is something that's just within the EE specification. So it specializes as saying, and I have my test XML, so test beans. Test beans in EE allows you to basically provide alternate implementations of your interfaces. And so what I'm saying for this test is, and you can see this is in my test resources, it's not in my production resources. This is saying in my test environment, I want to deploy the mock book service, which is the implementation of book service. And when this goes out, this is packaged into my WAR file, deployed on the application with my physical mock. I don't need to install Mockito. I don't need to try and make up any magic tricks to try and change how this double is mocked out. This is a real double that is replacing the real database service that would write to a database. So this is anything you can do in an EE environment. You can run on your application server. So this is the idea behind Arquillian. Is we're not trying to change everything. We're helping you do it the way you manually do it. You know, when you build your application and you drop that WAR file in and create your deployment, you're doing it all by hand. you can automate it through your CI to do all those deployments. But here, how are you going to do that for your developer? Are you going to make your developer, and traditionally up till now, your developer will create his WAR file and it will drop it on, either go through the console to deploy it, or have some kind of magic script that will deploy it on a remote system, or literally copy it into the application directory by hand. And then your application server will deploy that. Once it's deployed, then you'll open your browser up and you'll start clicking and testing. You might have some clients that you'll call and test these things. So what it's doing is taking all that manual legwork that you're usually doing and please correct me if any of you have not done that. Put your hand up. So everyone's done that. Everyone has created a WAR file and created that file and dropped it into their container, or they're running the application server through their IDE, so you might configure in Eclipse an instance of your application server to run against, and it then does exactly the same thing. But that's not testing. That's you clicking buttons to start that. And this is entirely Maven-based, so this is clean install. You run your Maven clean install on this, on your CI, and it will fire up the container. It will run that test against it. So this is, we're looking at this from a project sense. Maybe I haven't opened up the POM file, which is basically pulling in the Arquillian test dependencies. So all I've got is a dependency management block in my POM file to pull in all the Arquillian test dependencies. I don't need to do anything else other than say I want to run it on Arquillian Tommy remote. That's going to be my remote container. And that's an implementation. And again, there's like 15, 16 implementations at Arquillian for you to use for your application server. And that's it. So you're pulling it into POM file, providing this XML, this Arquillian XML, to say this is how I configure my application server. Run it. Just run it. And that's as magic as it gets. So you're taking all these manual steps that you're usually doing, putting that into a POM file and giving that to Jenkins to run for me. And at the end, I'll look up my results and call up Sonar and see how things have been doing on that side of things. So it's taking all those steps that we're normally doing in a manual sense to test our applications in the EE world and fully automating that. And again, the big step here, and I can't paint the picture enough, is you're building your image, your Docker image, which is your real application server. If it's a web sphere that's cost you $500,000 and it's very, very expensive and difficult to replicate on a developer box, because again, you run that on your developer box, that's all that's going to run on a developer box. You've got this mechanism where, hang on a minute, we've got a Docker image with everything run. We've trimmed it down to all the things that I'd like my developer to test against. Run with it. And it just does it for you. Is everyone getting this? Yeah, any more questions? It's actually worked out very well. Time's up.